This slide introduces the first configuration for the non-inverting amplifier. And this is the schematic for the non-inverting amplifier circuit. And the input signal is connected to the positive input terminal of the op-amp. The negative terminal is connected to ground, which is common between the input and the output of the circuit. Note that there is again no feedback. This is again an open-loop op-amp configuration. The equation that describes the output voltage is the same as before. The output voltage is the given by the difference between the two input voltages, multiplied by the open-loop gain of the operational amplifier. The input at the positive terminal of the op-amp is connected to the signal input. The negative input of the operational amplifier is connected to the ground. And the output signal is equal to the voltage difference at the two inputs of the op-amp, multiplied by the open-loop gain of the op-amp. This equation reduces to the input voltage signal multiplied by the op-amp open-loop gain. These arrows further illustrate the operation of the non-inverting op-amp. Both the input and output voltages are in phase and have the same polarity. To summarize, this slide is about the non-inverting amplifier with a positive input signal. When the input is positive, the output is also positive. In this slide, we are going to analyze the non-inverting amplifier with a negative signal input. In the previous slide we analyzed a non-inverting amplifier with a positive signal input. This is what the schematic looked like for the non-inverting amplifier with a positive signal input. The output voltage is the product of the open-loop gain of the op-amp and the input signal. These arrows show that when the input voltage is positive, the output voltage is positive as well. This is the schematic for the non-inverting amplifier, with a negative input signal. Note that the input signal is the opposite to what we had in the previous slide. The positive terminal of the input is connected to ground and the negative terminal is connected to the positive input of the op-amp. The equation for the output voltage is the same as before. The output voltage is equal to the difference between the input signals at the input of the op-amp, multiplied by the open-loop gain of the op-amp. The voltage at the input of the op-amp is equal to the negative of the input voltage. The negative input of the op-amp is connected to ground. The value for the op-amp input voltages is substituted into the gain equation for the open-loop op-amp. The red arrows show that when the input voltage is negative, the output voltage is negative as well. This version of the non-inverting amplifier has a positive input and generates a positive output. And this version of the non-inverting amplifier has a negative input and a negative output. In this slide, we have a short summary of the non-inverting amplifier. First, we have the non-inverting amplifier with a positive input. When the input voltage is positive, the output voltage is also positive. This is shown by the two green arrows. Next, we have the non-inverting amplifier with a negative input. When the input voltage is negative, the output voltage is also negative, as indicated by the red arrows. The output voltage is given by the product of the open-loop gain of the op-amp and the input signal. Both the input and the output are positive. The output voltage is given by the negative product of the open-loop gain of the op-amp and the input signal. Both the input and the output are negative. We have not covered both the inverting and non-inverting open-loop amplifier circuits. There are a few assignments that you can do for this section to improve your memory and understanding of the inverting amplifier configuration. There are a few details of this circuit that you should be able to recall from memory. These exercises will assist you in doing so. The first assignment is to redraw the schematic for the non-inverting amplifier, without referring to the previous slides. Repeat this until you are able to draw it correctly. Note the polarity of the input and output signals, as well as the connection of the two input terminals of the op-amp. Write down the gain equation for the open-loop amplifier in terms of the open-loop gain and the two inputs of the op-amp. Write down the gain equation for the non-inverting amplifier. This is the end of section 3, which is about the non-inverting open-loop amplifier configuration. The next section is a review on all the sections covered thus far, which is about both the inverting and non-inverting open-loop amplifier circuits.